Good morning everyone. This is Lalitha, Assistant Professor Electrical and Electronics Engineering Department. The today topic is Karnaugh Maps. It's simply called as K-Maps. First we can see about what are Karnaugh Maps. The Karnaugh Maps provide an alternative way of simplifying the logic circuits instead of using Boolean algebra simplification techniques. So you can transfer logic values from a Boolean statement or a truth table into a Karnaugh map. The arrangement of zeros and ones within the map helps you to visualize the logic relationship between the variables and leads directly to a simplified Boolean statement. The Karnaugh maps often used to simplify logic problems with 2, 3 or 4 variables. We can get the cell with using the formula of 2 per n. The n is the number of variables. For the case of 2 variable, we form a map consisting of 2 per 2. So totally 4 cells. It's shown in figure. We can have 2 row and 2 columns in 2 variable K map. The column variable is A. It represents 0 or 1. The row variable is B. It represents 0 or 1. So the cell combinations are 0 0 1 0 0 1 1 1. So we can consider the cell values are 0 1 2 3. In terms of min terms, we can represent the cell value as A bar, B bar, A B bar, A bar B and A B. For max term, we can consider as A plus B, A bar plus B. The third cell is A plus B bar. The fourth cell is A bar plus B bar. Likewise, we can draw the 3 variable K map and 4 variable K map. For 3 variable K map, the cell is 2 per 3, so 8 cells. So we have 4 columns and 2 rows. In the columns we have the variables of A, B. So the variable values are 0, 0, 0, 1, 1, 1, 1, 0. The row variable is C. So we can, the C may be 0 or 1. So the cell values are 0, 0, 2, 1, 1, 1. So the min terms are A bar, B bar, C bar. For second cell, A bar, B, C bar. Likewise in the last cell, A, B bar, C. Now we can draw the cell values. It's 0, 1, next 2, 3, 4, 5, next 6, 7. So we can represent 0 to 7 in 3 variable K map. Likewise we can draw the 4 variable Karnaugh map. It's 4 variable means the cells are 2 per 4, so totally 16 cells. So we have 4 columns and 4 rows. The column variables are A, B. So we can represent 0, 0 to 1, 1. So the row variables are C, D. We can represent 0, 0 to 1, 1. Totally we have 16 cells. The cells value is 0 to 15. We can represent the binary value from 0 to 15 in 4 variable Karnaugh map. The Karnaugh map is completed by entering a 1 in each of the appropriate cells. Within the map, the adjacent cells containing 1s are grouped together in 2s, 4s or 8s. When we are combining or grouping the adjacent 1s, 2 is called pair, 4 adjacent cells are quad, 8 adjacent cells are octet. We can map pair, quad and octet. Here we have simple example to draw the 2 variable Karnaugh map. We have the OR gate. The OR gate truth table is when the input is 0, 0, the output is 0. When the input is 0, 1, 1, 0 and 1, 1, the output is 1. So now we can draw the Y value in the Karnaugh map. The 3 cells are 1. Now we go for mapping. The mapping will be done in pair, quad or octet. The octet and quad is not possible here because we have 3 ones only. So we can map it as a pair. The first pair is 3rd and 4th cell. Now we can combine and the value is B. The second combination value is A. So the final answer for this example is Y equal to A plus B. Likewise we can convert any truth table or any expression in the form of Karnaugh map. It can easily simplify the expression. Now we have the another truth table with 3 variable, that is ABC. We can draw the K map for Y value. For Y value we have the 5 number of ones. First you can enter the 5 ones. Next we will go for the mapping. Here we have 5 ones, so octet is not possible, so we can try for quad. So in the quad we have the adjacent cells. So the first combination is quad. The value for this quad combination is B bar. The next we can try the pair with 1 cell. So the pair combination value is AC bar. So the answer for this example is y equal to B bar plus AC bar. The next exercise will be, let us simplify this expression using Karnaugh map. We have two functions, f1 and f2. And f1 we have the minterms and f2 we have the minterms. We can put the 1 for the following minterms and find out the answer. Next exercise is, draw the Karnaugh map for this truth table and find the simplified version of SOP, that is sum of product and product of sum forms. Next we can go for don't care terms. So don't care is another variable, another type of variable in Karnaugh map. So maybe the variable value is 0 or 1 in some cases. Okay, that case is considered as an don't care terms. In this truth table we can have the don't care combination. In this Karnaugh map we have the quad combination. The three variables are don't care, the one value is 1. So we can combine together and get the answer of AD. So we can combine the don't care combination with the ones. We can consider it is an adjacent cells. The next exercise is, design logic circuit that convert 4-bit binary code to XS3 code. And the ABCD is binary code, WXYZ is a XS3 code. So for this truth table we can draw the Karnaugh map for W, X, Y, Z. We can use 4 variable Karnaugh map. We can see some of the few simple example for K-maps. Here we have the function with the minterms of 1, 2, 3. So answer for this is A plus B. Here we have the minterms of 0 and 1. The answer for this map is A bar. The next example is 4 variable K map. We have the 4 variable W, X, Y, Z. The minterms values are 4, 5, 10, 11, 14 and 15. So put the ones in the above minterms, and now we go for the mapping, either the mapping for 8 adjacent ones or 4 or 2. First the possible 8 is not possible, so we go for the 4 possible ones. We can get the one combination of quad. The answer for this combination is B. Next the pair combination answer is A. So the output of this function is A plus B. The other possible valid groupings of a 4 variable K map is, we can map the corner ones, because when we are folding they can consider as an adjacent ones. When we are folding the papers or folding the map, we can consider the adjacent ones as a corner. The next K map is, next problem is, the minterms are 2, 3, 4, 5, 7, 8, 10, 13 and 15. We can put the 1 for these minterms and go for the mapping. Try for the octet mapping, otherwise we can go for quad. If there is no possible for octet and quad, then we go for a pair. So the answer for this problem is BD, A bar B bar C plus A B bar D bar plus A bar B C bar. Next we go for 5 variable K map. The K map is possible up to 4 variable only, but using 2 4 variable K map we can get the simplification function using 5 variable K map also. So in this 5 variable K map we have the 5 variables x1, x2, x3, x4 and xy. The 4 variable K map consists of first 4 variables. The xy is considered as 1 for one 4 variable K map and consider 0 for another 4 variable K map. Using this we can solve the 5 variable function. The minterms of the 5 variable function is, in this problem, 6, 7, 8, 9, 12, 13, 18, 22, 23, 24, 25, 28, 29. We can mention up to 0 to 31 in 5 variable K map. In 4 variable K map we can mention up to 15. In 5 variable K map we can mention up to 31. So we can get the answer through mapping. Here also the same case, the mapping with 8 adjacent ones or 4 adjacent ones or 2 adjacent ones. So the don't care combination is input combination that will never occur. So the corresponding output can either be 0 or 1. The don't care condition can be used to help simplify Boolean expression further in K maps. They could be chosen to be either 1 or 0 depending on which gives the similar expression. We usually use the notation summation d to denote the set of don't care minterms. For example, the function b in the odd parity generator for BCD can be written as p equal to summation m 0, 3, 5, 6, 9 plus summation d. The don't care combinations are 10, 11, 12, 13, 14, 15. For comparison, we can show the without don't care combination and with don't care combination. The another problem with the don't care combination is we have the don't care minterms are 0, 2, 5. In that cell we can put the d. The d can be combined with adjacent ones. So here we have the two quad combination in two possible ways. The first one is the third column and first row combination. The second possible combination is the third column and first and second column quad combination. So we can get the two possible answers for this problem. The BOA simplification is simplify this minterms in sum of product and product of sum. A prime implicant is a product term obtained by combining the maximum possible number of minterms from adjacent squares in the map. Use bigger grouping where is possible. It is no redundant groups. We have the two possible combination for one type of problem. We already shown one example that is called redundant. This is one of the example for your practice solving this problem using Karnaugh Map. This is also another example for your practice. It is using max term. In the max term we can put the cell value as 0 and we can combine. It is write the value as product of sum. In minterms we can write it as a sum of product. The disadvantage of K map is it is not suitable for computer reduction. It is not suitable when the number of variables involved exceed 4. Care must be taken to field in every cell with the relevant entry such as 0, 1 or don't care terms. So these are the few examples. Minimize the following Boolean functions by K map. Here we have the 4 variable K maps with don't care and without don't care condition. We have the Boolean expression and minterms also. So try it and practice the K map problems. Thank you.